Good day to everyone. I'm Dr. Tolosa, and today we're going to talk about all these topics. We have selection of study participants, we have sampling, and we have sample size calculation. For our part one, we'll tackle selection of study participants and sampling. And then for part two, we will have sample size calculation. At the end of this session, you, as the learner, are expected to understand the different types of sampling techniques, distinguish between probability and non-probability sampling, identify the best possible sampling design given a particular set of objectives, and be able to compute for the sample size of your proposed study. Sampling, as you would know, is the process of taking a sample. But what is a sample? According to the plainest or the simplest definition, and that one we take from the dictionary. A sample is a representative part or a single item from a larger whole or a group, especially when presented for inspection or shown as evidence of quality. And this is akin to the word specimen. The second one, which is probably more relevant or more aligned with us, is a finite part of a statistical population whose properties are studied to gain information about the whole. When we talk about sampling, of course, we have to understand the relationship of the sample to the population. So let's talk first about the population. The population is that complete set of people or participants or individuals who have a specified set of characteristics. Sometimes the word population has the context of geographical location, like the population of New Zealand, the population of barangay Tag-Ulan in town, so and so. Now, when you talk about the target population, this is in the context of the study, the large set of people to whom the results will be generalized. So sometimes the population in general can be your target population too. Now look at this circles, one, the bigger one encompassing the smaller ones. When you talk about the accessible population, that is a subset within the target population that is available, accessible, reachable to you as the researcher. Because it's possible you're interested in this really big group, but you don't have any way of reaching them or gaining access to them. So how could you get the responses? So that target population could have an accessible component which you are able to go to or come through to ask or to enroll in your study. Now, the sample, the one that you're targeting now to get, is the subset of the accessible population that participates in your study. And then when you talk about that sample, within it, you have the individual participant. So the participant can be a person, as we usually think, no, like, for example, they're respondents, or you're interviewing them for something, you're asking some questions about how they sleep, how do they feel. So participants are the persons, or maybe records of persons or human information who are directly involved in the study on an individual level. So inside that sample, in this drawing, the participants are those happy faces inside. In the past, and probably in some lectures, you will still hear it being used. In the past, the common term that was employed to refer to participants was subjects. But now, because we're coming into new paradigms, no, and mindsets, we prefer the term participants because it's more, as the term connotes, participatory. They're not like subjects who are made to follow what you say. And then, if you can please remember, when you talk about your participants, do not say the samples that we enrolled. These are human beings, so please do not call them samples. It's probably appropriate to say samples if you're talking about, let's say, blades of grass being studied for what species they are from a field, for example. But when you talk about people, refrain from using the term samples. In statistics, that participant that we're talking about, this is sometimes what they call the sorry, the elementary unit. Why do we sample? We sample because it is often very difficult, if not impossible, to study the entire population. But sampling comes with its own disadvantages, its own caveats, so that when researchers do sampling, they must ensure that the sample that they set up can be studied within reasonable expense and time requirement, is large enough to allow valid generalization of the study findings to the population, as in control of random error, and that it is representative of the population they would like to study. And here you do control of systematic error, uh, in particular, selection bias. The following are criteria of a good sampling design. The sample should be representative of the population we're interested to study, and it should reflect the characteristics as well as the variability of the population. Of course, needless to say, the sample size should be adequate. It should be sufficiently large so that it allows reliable generalization about the entire population. And then you must ensure that there's practicality and feasibility of the sampling procedure, in that it is simple and straightforward, easy to understand by any member of the team, and the economy and efficiency of the sampling design will ensure the highest level of information that could be obtained at the lowest possible cost. In sampling, there are many potential sources of error. For example, those errors could be those directly related to the sampling, because the sample is not the whole population, and the sample may not be reflective of the truth in and of the population, and the sample may not be large enough or sufficient in number. And then there are also errors that are not really arising from the sampling, and they call them the non-sampling errors. And here you may see poor sampling methods, a problem with a questionnaire or the thing that you use to measure that which you're measuring, no? And then possibly other behavioral effects, wherein people answer with good answers because they feel they'd be regarded better. So the non-sampling errors could be due to systematic error, also known as bias, and this could come in the form or along the domains of selection, detection or measurement, and other methodologic errors. When we talk about the sample and the population, it's integral to our study that we know what our inclusion and exclusion criteria are. Because you're coming from population, you say, we're interested in this group of people. But who among those people could actually enter the study? So a clear understanding is essential so that you could come up with a good design and thereby a good sample. The inclusion criteria, so that's like the plural, no? Criterion singular, criteria plural. So madami to. These are characteristics. And these are qualities of the target population that you want to study. So what are the main traits of the target population that are important or relevant in relation to the research question? So in considering this, the usual age, sex, sometimes this include the geographical and temporal characteristics, sometimes behavioral characteristics like smoking. Are they smokers? Are they alcohol drinkers? And then sometimes the clinical or the medical history. Do they have other diseases? Do they take medications? So these are qualities or traits or factors present in the target population. Now, when you determine these criteria, there could be you know, a question of trade-off could be posed to you, like a trade-off between feasibility and scientific validity. For example, if you want to do a study on Filipinos, the most valid sample probably you'll get will be people across the Philippines. But if you're doing this as a medical student and you have so many subjects in second year or in third year when you're actually conducting it, how could you possibly go to, let's say, Bukidnon to carry out the study or go to Pagudpud? So you'll have to revise and just probably target the people who you could actually reach. So this is what we mean when we say sometimes there is a trade-off between your feasibility and scientific validity. But you should not sacrifice scientific validity at any point. So you try to get the best balance wherein it's still valid, it will still hold, and yet it's easy enough or doable enough that it will allow you to complete your project. Now let's talk about the exclusion criteria. The first thing I'll tell you is that the exclusion criteria are not or should not just be the opposite of inclusion criteria. This is an error that I was prone to when I was a student myself because I didn't know anything or I didn't know a lot about research then. For example, you say that their inclusion criteria, patients aged 18 to 65. So if you write that down as inclusion criteria, do not write as exclusion below 18 and above 65. Because it's obvious. Sinabi mo na nga 18 to 65, edi hindi na yan exclusion criteria. Ang exclusion criteria are characteristics possessed by a potentially eligible participant na by possessing these characteristics now makes them ineligible. In Tagalog, it's like, pwede na sana, pero hindi pala, kasi meron palang ganito. So, certain subsets of the population may be deemed to be not suitable for study because of a variety of reasons. For example, there's higher chances that they will be lost to follow up. Or maybe they have inability to provide good data. There could also be exclusion criteria when a person has conditions that render them like being at high risk for adverse events, let's say in the case of an experimental study. So understanding our populations, our sample and inclusion and exclusion criteria, let's now go to the sampling methods. In general, sampling methods will branch out into two: probability sampling and non-probability sampling. The main differentiating point of the two main branches is the answer to the question, does everybody in the population have an equal chance to be selected? In probability, the answer there is yes. In non-probability, the answer is no. So this is how the entire diagram looks like, and we will take a bite of these one by one. Under probability, we have simple random sampling, clustered sampling, systematic sampling, and stratified random sampling. Under non-probability, we have convenience sampling, consecutive sampling, quota sampling, and purposive or judgmental sampling, and snowball sampling. So these are the four probability sampling methods mentioned earlier. Note that probability sampling assumes that you have the sampling frame, which means that, in simple terms, the complete list, no? Or at least the count. Like, kung hindi mo man alam yung mga pangalan ng mga nasa listahan, at least alam mo na, 256 sila lahat. Because if you know the count, then you can do random selection, or you can stratify them and get the counts. So you must have that, the complete list or the count of the possible participants. In probability sampling, each unit in the population has a known non-zero chance of being included in the sample. By being there, alam mo na, may chance ka mapili. So in some literature, this is referred to as random sampling or random selection. So parang in some references, when they say probability, they go straight to mean random sampling ito. At this point, let me just introduce this tip on caution or on the terms used. Random selection versus randomization. The two terms are not equivalent because randomization, that thing you see in randomized controlled trials, which are in nature experimental, no? Randomization is the assignment by chance to one of two or more intervention groups. So assignment of treatment ito by chance. Random selection, which we use when we talk in the context of sampling, is the possibility of being picked out from a list or a group where every member has the same chance as any other of being picked out. So that's the difference between the two. So when you write your proposal and then you're just describing how you're going to pick out your participants, do not say we did randomization, because that would be incorrect. So let's look at the first, simple random sampling. Simple random sampling, or SRS, works the same as a raffle draw, where you think of everyone having one raffle ticket. And the commonly employed means for this, noong unang panahon, we only used the fishbowl method or maybe draw lots. Yung puputulin mo yung mga papel, you will write an X mark or a check mark on them and then you pick out. So the ones with the check, sila yung winner, gano'n. But recently, when we had computers and other applications, we had table of random numbers. We now have random.org. Random.org is one of my favorites, no? So it looks like this when you put it, when you go to the website, it looks like this. And one of the functions is random integer generator. So if you want to generate an X number of integers, of random integers, then you just say that each integer should have a value between this and that. And each integer would intuitively, represent one person. So in a list, let's say, of 869 people, you say, I want a value between 1 and 869, and I need 126 because kunyari yun yung lumabas sa sample size computation. Then if you press go, it's going to generate those numbers for you, and then you can pick out the individuals from the list that you have. In systematic sampling, this is like a slight variation of simple random sampling. What you do is you identify your sampling frame, and then you number each unit in the sampling frame, and then determine the sampling interval K, where K is the ratio of the population size big N to the sample size small n. So if big N, let's say, is 12,900 and you need a sample size of 300, your sampling interval is 12,900 over 300, which gives you 43. So a K of 43. This means that your sampling interval is per 43. So kukuha ka ng isa you will get one participant per 43 people. So what happens is that you select a random start, and the random start can be chosen in any of those ways we mentioned for simple random sampling. Then let's say you got um, person number 5 on the list. Then get number 5, and then you select every kth item, which is like every 43rd item in the sampling frame until you achieve the sample size na 300. So that's systematic. It starts out randomly, and then nagkakaroon siya ng sistema as you go along because you're employing the sampling interval. Stratified sampling, or what you will find in some references as stratified random sampling, employs a division or a stratification of the sampling frame. So the total population is divided into strata. These are homogeneous groups that you identify because they have some shared attributes. So for example, you're talking about doctors, but you know that within that group of doctors, within that entire population of doctors, there's like a hierarchy. The senior residents, the junior residents, the new consultants, the junior consultants, and the senior consultants. Or possibly, for example, people categorized according to income, or maybe sex, male, female, or category of training, let's say. So random participants are then picked up from each stratum, are picked from each stratum. And the analysis that comes out of it can be made for each stratum or across the strata. So you can compare the individuals within the stratum, or you can compare the strata against one another. The term proportionate stratified sampling, no, refers to the method wherein you get a number per stratum that is proportional to how large that stratum is. The drawing that we have on the right is kind of simple, but you see the neon green figures, there's 3 of them. So there's only one from that group. The yellow figures, there's 3 of them, so you get also one from that group. But the purple figures, there's 6 of them. So what you do is you don't get one, but you get 2 because that's like a representation of 1 per 3, which is similar to the neon green and the yellow ones. In cluster sampling, groups rather than individual units of the target population are selected at random. A good example of this would be like street blocks in a large barangay. So let's say you're starting with a city or a municipality, and then you try to randomly select which barangay, and then or which block. And then when you select a block, lahat nung nandun sa block na yon na households, isasama na sila. So cluster sampling is done by selecting the entire cluster rather than pick out randomly individuals from that cluster. Another type of sampling that was not shown in the big diagram earlier is multi-stage sampling. And this is thought to be an extension of cluster sampling, like a more complex form of cluster sampling. So what happens is that populations are divided into groups, and clusters of selected people are split into subgroups at various stages to make it simpler for primary data collection. I saw this study to show to you as an example. It's by Gupta, Nupur et al. And what they did was a study entitled Rapid Assessment of Visual Impairment in Urban Population of Delhi, India. So how did they sample? They identified it as a multi-stage cluster sampling. So they chose to study the East District of Delhi. In that selected district, there are 3 sub-districts. So out of those, pipili sila ng isa. So one sub-district, that of Prit Vihar, was randomly chosen. Now, inside Prit Vihar, there are 27 administrative wards. So out of those 27, they chose six, randomly chosen for the study. So in the six randomly um, in the six wards randomly chosen for the study, they identified 600 census enumeration blocks. And out of those 600, they chose 24. So you see that they went through various stages. So random select, random select. So at the end, they chose clusters of blocks for the study. So this is an example of multi-stage sampling. So that finishes it for probability sampling. Now we go to non-probability sampling, and this is the right side of the drawing of the figure earlier. So non-probability sampling is a method of selecting units from a population using a subjective, meaning a non-random method. So it does not require or does not need to know a complete survey or sampling frame. So it can be fast, it can be easy and inexpensive. But then it has, there's a toss up too, there's a trade off. So concerns would include the following. Is the sample that you're getting representative? What is the probability of any one element in the population being selected? And for that matter, does each element have a chance to be selected into the sample? The first one for this general group of non-probability sampling would be convenience sampling. The researcher recruits anyone who is available, and this could be likened to accidental or haphazard sampling. And in the early days or in years past, one of the usual examples for this would be the people you interview who come out of the cinema, and then you ask them what did they think of the movie, and they would just exclaim ang ganda ganda, and also the reporter would just give the mic to anyone who passes. So that's like an example of convenience sampling for market research, not health research. Number two is consecutive sampling. Participants are entered into the study one after the other over a specified period of time. So for example, you will say, lahat ng nagpatingin sa emergency room na to from this month to this month, ganitong oras. Consecutive sampling is referred to in some references or often considered as the best non-probability sampling method because by doing the invitation or recruitment consecutively, it can reflect the natural total spread of people in a particular situation or context. Like, for example, across all hours of the day, across all the days of the week, throughout the seasons of the year. So if you could not get a random sample because you do not know the frame, then consecutive sampling may be the thing for you. Number three is quota sampling. And this is often utilized in the context wherein data collectors are given quotas or a minimum number requirement to meet in certain scenarios or research settings. Research assistants may be given instructions to just keep on interviewing household heads, for example, in a given locale until the pre-specified quota for that accessible area has been reached. Number four is purposive sampling, which is one of the commonly employed, if not the most commonly employed type of non-probability sampling. So the sample is thought to be representative of the population, and it's selected based on an expert's subjective judgment or based on some pre-specified criteria. So that could be inclusion, exclusion criteria, others. And the last one is snowball sampling, or which I prefer to call chain referral sampling. So if you think of a snowball rolling down the mountain, it starts small, and then as it rolls down, it grows larger and larger and catches momentum. Chain referral naman is like you get one chain in the link, and then the next one, the next one, and the next one until humaba. Snowball sampling was first used in research with what we call hidden populations as the target study participants. For example, children in conflict with the law, commercial sex workers, and other, if I may use, for lack of a better term, compromising situations. Um, this was employed because of the difficulty recognized by researchers, no? The difficulty of producing a sampling frame and identifying members of the population. The first participant, or the index, identified to be a member of the so-called hidden target population, will be interviewed. And then he will subsequently be asked to reach out to other members of the hidden target population, yung kaibigan niya, yung kapatid niya, until the sample size is completed. So that's the end of the examples or the entries under non-probability sampling. And so at this point, we end participant selection and sampling methods and designs. And then we will proceed to part